Scientists have discovered a new planet known as Proxima b.
We have found a terrestrial planet orbiting Proxima Centauri. It's the nearest exoplanet we will ever find because it's the nearest star to the Sun.
Have you ever dreamed of visiting another world that could be like ours? Well, dream on, because it's not going to happen anytime soon. But some people are not giving up. They have a plan to send some miniature probes to a nearby star system where there might be a habitable planet. How do they do that? By using a huge laser that could fry your eyeballs. But before we go any further, let me ask you something. Would you do it? And by it, I mean, would you sign up for a space journey to a planet that's like Earth but 4 light years away, even though you would never get there alive? Share it with me in the comment section. Now let's get started. You may have heard that a team of astronomers recently discovered a planet around Proxima Centauri that could be habitable. It's called Proxima b, and it's only 4.22 light years away from us. That's about 25 trillion miles, or 40 trillion kilometers if you prefer. That sounds like a lot, but it's actually very close in cosmic terms. It's like having a neighbor who lives just across the street, if the street was the size of the solar system. So naturally, some people are very excited about this discovery and want to send a probe there as soon as possible. After all, who wouldn't want to see what this planet looks like? Or even better, if it has life on it. Maybe we could find some friendly aliens who would invite us over for tea and cookies. Or maybe some hostile aliens who would try to eat us for lunch. Either way, it would be a thrilling adventure. But how do we get there? Well, that's where things get tricky. You see, traveling to another star system is not like taking a road trip to Disneyland. It's more like taking a road trip to Mars, except much, much harder. Let me give you some perspective. The fastest spacecraft ever launched by humans was NASA's Juno probe. Juno was so fast that it reached speeds of about 165,000 miles per hour when it got there. That's faster than your morning coffee kicks in. But guess what? Even at that speed, it would take Juno more than 17,000 years to get to Proxima Centauri. That's longer than the whole history of humans on Earth. By the time Juno got there, we would probably be gone or turned into something else. Maybe we'd be cyborgs or zombies or extinct. Who knows? Well, you can guess the answer. But that's not all. Juno is a pretty big and heavy spacecraft, weighing about 8,000 pounds or 3,600 kilograms, which is more than a whale. But not the blue ones, they are enormous. Juno also has a lot of awesome gear and equipment that allows it to study Jupiter and its moons. But to fly to another star system, we'd need something much smaller and lighter. Something that could blast much faster. It's called Breakthrough Starshot, and it's a crazy and cool project started by some rich and famous people who have a lot of cash and curiosity. They have a dream of sending super speedy tiny probes to Alpha Centauri, the closest star system to our own. These probes would have light sails attached to them, which would be 1 gram in mass and 1 centimeter in size. These tiny sails would catch the energy from a massive laser beam that would be fired from Earth. According to the people who came up with this idea, this laser would boost the probes to a mind-blowing 20% of the speed of light, or 216 million kilometers an hour, in case you were wondering. Now, before we start planning our interstellar vacations, let's consider the practical side of this bold idea. First off, we're talking about some serious cash and brainpower. We're looking at a bill of about $10 billion, equivalent to building the world's largest particle accelerator, the Large Hadron Collider, and that's just for one launch. Imagine how much it would cost to send multiple probes to different stars. But even if we manage to pull off this crazy stunt and send these probes on their way, space is not a piece of cake. They would have to deal with a lot of nasty stuff like interstellar dust that could scratch their sails, cosmic rays that even Superman would think twice about, magnetic fields that could mess up their signals, and the occasional space crash that could end their journey. All this before they even got a chance to say, "Hi Proxima Centauri." But let's say some of these probes managed to pull off a miracle and reach Proxima Centauri and its planet in one piece. They would have very limited capabilities to study them. Remember, these are wafer-thin probes with pocket-sized instruments, so they could only do a basic analysis of the star and planet as they zoom by at super speed. Like tourists trying to take selfies from a speeding space train. No orbits, no landings, and certainly no greetings sent to any possible alien life forms. And it's ironic that even if these speedy probes do manage to send back some data from Proxima Centauri, we'd be in for a big space shock. The data would take over 4 years to travel back to Earth at the speed of light. By the time it arrived, who knows, we might have gotten all the latest space gossip from other less patient sources. So what are these other methods that could help us learn more about Proxima b and other exoplanets? Well, there are a few options that don't involve shooting wafers with lasers. Let me tell you about them. One of them is building better telescopes that can actually see the planets, not just guess where they are. You see, most of the exoplanets we know of today were discovered by indirect methods, such as measuring the tiny dips in starlight when a planet passes in front of its star, or the subtle wobbles in star motion when a planet tugs on its star with its gravity. These methods are great for finding planets, but they don't tell us much about what they look like or what they're made of. They could be rocky, or gassy, or watery, or even cheesy. Who knows? That's why we need better telescopes that can directly image and analyze exoplanets from Earth or from space. These telescopes could be on the ground, like the Extremely Large Telescope. Yes, that's its real name, and yes, it's extremely large, so you won't miss a single cosmic selfie. It's being built in Chile, and will be the largest optical telescope in the world when it's finished in 2025. Or they could be in space, like the James Webb Space Telescope, that was launched on December 25th, 2021, and is now the most powerful infrared telescope ever built. Now, there's another way to reach the stars. Our current rockets are like regular cars of space travel, burning fuel to move. They do fine for short trips to places like the Moon or Mars, but when it comes to reaching other star systems, we need something better. We're talking about developing new space engines. These engines would use different kinds of energy like nuclear power, or even harnessing the power of the sun with solar sails. With these engines, we could potentially make a spacecraft go much faster than they do now. It's like upgrading from a tricycle to a sports car. So instead of a journey that takes thousands of years, we're looking at trips that could take mere decades, or even just a few years. Your descendants could be the ones to explore the stars in style. So in the end, visiting Proxima b is not a total pipe dream, but it sure is a tough nut to crack. It would take a lot of time, money, tech, and luck to pull it off. And who knows if it's even worth the hassle, considering what we could learn from other ways. But hey, who am I to squash your space dreams? If you're still keen on going there, you can always hop on SpaceX's Starship, the ultimate ride to Mars and beyond. Maybe they'll have a sweet deal on Proxima Centauri someday. Just don't forget to pack your sunscreen and your spacesuit. And while you're on the trip, why not check out our other videos?